Good evening and welcome to the Bella Vista Radio Club's September virtual meeting. My name is Tom, call sign W5XNA, and I am the current president of the Bella Vista Radio Club. Thanks for joining us tonight. I hope that you and your family are continuing to do well. As I record this message, there is still no timeline for resuming on-site club meetings. We will do so only when it is safe and in conformance with the state's guidelines. Although not an ideal replacement, I trust that you have enjoyed the virtual meeting presentations. There has been a lot of very positive feedback. Thanks to all of the many presenters, those who have participated online, and a big thank you to Wayne Patton, K5UNX, for putting the videos together and on the air. While looking over the BVRC membership roster, I noted that several of our members are not listed as being members of the American Radio Relay League, the ARRL. If you are a member but unsure if you have your membership acknowledged on the club's roster, please send me or Ron Evans, K5XK, an email. If you have not joined the ARRL, I want to encourage you to do so. Membership benefits include, probably the most important benefit is supporting the oldest and largest advocacy group supporting amateur radio in North America. But there are many other benefits, some of which include Logbook of the World, licensing and VE programs, education and training, regulatory and advocacy, contests and awards, volunteer monitoring program that's now in place, amateur radio emergency service, bulletins, QST or on-the-air magazines, paper and digital, QEX, NCJ, and on-the-air magazines, free in digital form. Publication archives going back to many years, and email forwarding. And these are just some of the reasons why membership is important and beneficial. I would like to see how close we can get as a club to 100% participation in the coming months. I think just receiving QST every month makes joining worth the cost of membership. So QST, QST, QST. Please join the over 160,000 members of the ARRL. Thanks. Now for tonight's presentations. First, we have Chuck Korsendorfer, Kilo Mike 5 Golf, who will be explaining the antenna that he is building in his backyard and the history behind its design. First licensed as a novice in 1967 in upstate New York at age 16, call sign WN2ZPW. Upgraded to general and advanced license with the new call sign of WB2ZPW. Upgraded to extra class in 1978 in California. New call sign of KA6CPL. Moved to Arkansas in 1980 after getting caught up in a major flood. New call sign and current call sign, Kilo Mike 5 Golf. Worked for 40 years in the electrical construction field in Northwest Arkansas. His major interests in radio is HF contesting and DXing. He helped K5GO and N5DX with building and operating from their large contest station near Harrison starting in the year 2000. He organized the W1AW/5 operation from Arkansas in the year of 2002, when Arkansas hosted the W1AW call sign during the annual running of the IARU contest. Recently back on the air after a 4 to 5 year absence. Next, we have Mark Watley, K5XH, who has been featured in 2 previous video presentations. His knowledge and skills make him a valuable resource, Elmer, and a good friend. His bio reads, I got my novice license in the summer of 1963, upgraded to a conditional in 1964. Grandfathered into a general when the conditional class was abolished. Joined the Army in 1968, attended school in Fort Monmouth, New Jersey, wound up getting sent to Korea instead of Vietnam like most of my class. Got assigned to the American Forces Korea Network, and spent a year tending a Gates AM broadcast transmitter. Spent my last year in the Army at the Mars Station in Fort Sheridan, Illinois. While at Fort Sheridan, I made the trip to Chicago, the FCC office there, and got my advanced in 1971. Once out of the Army, I passed the extra test in Kansas City in 1975. I became interested in RTTY operations while I was in high school. That interest led me to another interest, that of what is now called personal computers. There was a ham on the West Coast that was using a commercial office computer to send and receive RTTY signals. I was fascinated by the prospect of using an all-electric means to operate RTTY. In 1957, I built a little computer using an Intel 4040 processor. This was about 6 years before IBM came out with the PC. That led to a few years of being in the computer business. My interest in RTTY continues to this day. In the late 70s and early 80s, I set up an EME station and enjoyed that mode for a couple of years. Sometime around 1980, I got interested in flying. I spent about 15 years flying, first charter and then corporate aircraft. Sometime around got out of the flying business when the owners sold the planes. Went to work for Carnier in Springdale for a few years in their drafting department. I currently work for a contract electronic manufacturer. I do mostly PCB layout and embedded programming. I don't really have any awards to brag about. Both of these guys have a wealth of knowledge, and we appreciate them sharing some of it with us tonight. Well, now it's time to begin the presentations. We appreciate any questions and feedback that you leave in the chat box. So on with the show. Go.
Okay, hi everybody, I'm Mark, K5XH, and I'm going to show you where I work, a little bit of where I work and what we do over here. We populate circuit boards for customers, is what we do. And it all starts with one of these. This is a bare circuit board. I'm sure you guys have seen these many times, but this is what a bare one looks like when we get it. We do not make boards here because of the chemicals and the EPA and all the restrictions that have to do with the chemicals and the disposal of the waste and all that kind of stuff. So there are board houses out there. This is what they do. So we get a board. It looks like this. And the first step that goes through is we put it in this machine. It goes in a little slot over here on the side. I won't go over there because can't get to it. But this machine is a screen printer, just like they print T-shirts or something like that with. And what we've got in here is a metal screen that's in here that's really tight. I'll pull it out here a little bit so you can see it. Now that I know how to put it in there, looks like that. And you can see there's lots of little bitty holes in there. I don't know if you can see my hand through there, but this really tight stainless steel screen has these little laser cut holes in it. Everywhere there's a hole is a spot that solder paste will be placed on the bare board. Now this is not for this board, but you get the idea. So the board comes in on this side in a track and comes over here in the middle. With this is in place, then there are two squeegee arms that are not on here right now because they've got it all cleaned up. And we have this solder paste that looks like this. You can see what it looks like. It's kind of like thick toothpaste. And what that is solder particles that are emulsified a little bit and with some flux and I don't know what all else. But this is what is squeegeed across this and deposits solder paste on all the little pads that are exposed from this board. That's everything that's not green, or the white stuff obviously is just printing. But so every one of these little pads winds up with some of this stuff on it, if you're lucky. And the squeegee then, whenever it gets done with its job, the conveyor moves this board out of here along this path right here, and then it goes into this big machine. This is called a pick and place machine. And what it does is it takes all the little parts and places them on the board in the proper place. This requires a bunch of programming. The operator of this machine and whoever else has to go through and say, okay, the part off of, say, this reel goes on a particular spot on the board with a particular rotation and everything. We don't have very many parts set up on this, but normally these feeders have the parts on them. They come in reels that look like that. These are resistors. There's 5,000 of them on this reel. This reel, by the way, costs $23. And these happen to be 0 ohm resistors. So for a fee of $23, you can get 5,000 little bitty short circuits. So if you need anything, there's where you get them from. So it goes in here. This thing maneuvers around. It picks up parts out of these reels and sticks them down on the board. And the only thing that holds everything in place at that point is the viscosity of that solder paste. So when you get through with that process, it comes out and slides over here. We have 2 of these machines. These are more or less identical. And they're in series. So this machine, which it looks like I've got set up for bigger parts, sits there and puts more parts on the board. And then when it comes out the other side over here, it comes out on this little conveyor, and it runs along to right out of here and stops. And an operator can sit here and visually inspect it at that point, make sure that everything got put on the board and there's no really bad mistakes. But at this point, when you're looking at one of these boards that's got all the parts on it, you can literally just take your hand and go like that and wipe everything off, because there's nothing really holding anything in place except that solder paste. So the next place is it goes down to this track right here. And this track moves pretty slowly, probably about that fast, just about like that. And it pulls this board through this big long reflow oven. And the reflow oven has got 5 different temperature zones in it. So it starts out kind of warming everything up, and then it gets a little hotter, and then it levels off for a while, and then when it gets down toward the end, there's a big, huge increase in the temperature. And at that point, all that solder flux gets reflowed on the board here, or melted and flowed, and then it comes out the other end. It's pretty hot at that point, but there's some fans down there to cool it off. At that point, all the surface mount parts are on this board. So the next thing that has to happen is some parts are what they call through hole. And this board has got a bunch of headers that are through hole. That means that you drop the part in from this side, but it has to be soldered back here. So there's not a whole lot of them on here. Most of them are connectors. There's connectors here and stuff like that. So then an operator over on the other side there drops all those parts in, and we won't go over there, but the big machine that's right over here is a wave solder machine. and a kind of a flow of molten solder comes up, and this board goes across it, and it solders everything on the bottom side of the board. And that pretty much is it. Now there's some operators here that put on wires and things that cannot be machine placed, and we have some ladies there to do that. And that, in a nutshell, is what we do here. And that's about it, guys. I don't mess with this too much. I work in my office in here and do circuit board design and microprocessor programming. So that's my main job here. So, guys, that's it. I'm going to show you a little bit about how to solder surface mount components onto a board. It's not a big deal. Anybody can do it, but I'll show you what it takes to do it and do it kind of right. So we'll adjourn right now and go in there and do that. Okay, hi everybody, it's Mark again, and I'm going to show you guys some of the parts that we deal with here to give you a sense of the scale that's involved. And I put a few of them here on this little index card, and I'll try to show you a little bit about them. These are all surface mount parts. This one here is pretty large. They have a non-metric nomenclature that they call these things by. This is called a 2512, which means it's 25.25 this way and 0.012 or whatever this way. This is pretty good size. We don't do much of these unless we require a high wattage part. This is a 1206. Next one down a little bit. Some of the more common ones are these last two. This is an 0805, which is 0.08 by 0.05. This is an 0603, which a lot of people are switching over to now. And all these are resistors. This is an 0805 capacitor, so it's the same package size, but it's a capacitor instead of a resistor. So when you're on the circuit board, you just put an 0805 footprint down, and you can put either a resistor or a capacitor on it as long as it happens to be that size. To go even further, we build product here that uses these guys. And if you can barely see that, that's an 0402 part. And you can see how small we're getting now. Your iPhone probably has some 0201 parts in it, which are even smaller yet. You can't hardly see them. And there's another size even smaller than that. These resistors happen to be those, I think these are the same 0 ohm resistors, but the value doesn't matter. If that were a 10 mega ohm resistor, it would still be in that same package size. Here's some IC type things that we do commonly. I thought I'd show you a couple of these. This little package here is called a SOT23, and that is a transistor, a single transistor in one package. It has 3 leads, just like a regular transistor would be, but as you can see, it's pretty small. This is the same sort of package. This is called a SOT235 because it's got 5 leads. This happens to be a single operational amplifier, op amp. You get up into packages like this. This is a PIC processor. I think that's probably a 48-pin PIC processor. And you notice how, if you can see it in the video, how these pins are spaced. Here's another part that has much tighter pin spacing. And all this stuff has to be mounted on circuit boards in various ways to make the circuit work. So what I'm going to do is I'm going to move this out of the way here, and I'm just going to solder a couple of these onto a circuit board to show you kind of how I do it. I know everybody's got their own way, but I'm going to show you how I put some of these little 0805 parts onto a sample board over here. So I'm going to move that out of the way a little bit. I'll move the board over here. And you can see on this board there's all kinds of packages on this board. Some of these, here's like this part right here, I don't know if you can even see it, that's a SOT235. That's one of these little guys right here. An 0805 part is something that would go on these pair of pair of pads right here. That's C18 and C26, for instance. So what I'm going to do, I'm going to turn the board around a little bit so it's better positioned for me. And I'm going to put one of these resistors, even though that's a capacitor that goes there, it doesn't matter. I'm going to show you how I solder these parts on the board. So what you do, and you do not need a big soldering iron or a little soldering iron. I use this one right here. That's got about 1/8 of an inch chisel type tip on it. This is a Weller temperature controlled iron set to about 775 degrees or so. There's two things you need to do. You need to keep the soldering tip clean and well tinned. And to do that, I use this stuff right here. And this stuff is kind of important. You kind of waller it around in there a couple of times. You take it out and you make about one swipe on your sponge, and now you've got a nice, clean, bright tip, and that's what you need. So here's how you put these little bitty parts on your board here, and you don't need anything special. You need solder and a soldering iron to start with, and you come down and you put a little solder on just one of the pads that's going to go to that part, not both, but just one. And you put a little blob of solder on there like that. Probably can't see that, but there's a little bitty blob of solder on that pin right there. The other thing you really need is a good pair of tweezers. You can see these are stainless steel. They're needle point. You can actually hurt yourself with these things. In fact, I poked my hand with them earlier today. And you come down and you pick the part up. And you make sure it's flat against the circuit board. And if it's not, you can touch it, push it down just a little bit with your soldering iron to make sure that it's flat. And then you come over here and you put the part kind of next to the solder blob. And when you melt the solder, you push the little part over onto the pad. You use the soldering iron as a stop so it doesn't go any further. Now that part is stuck and it won't come loose. Then you go back and you solder the other pin, except you do one more thing. There's some magic fluid here that you almost have to have if you're going to do circuit board stuff. Looks like that. That's solder flux. That's liquid solder flux. You can get this stuff on Amazon. We buy it by the gallon here. So, and you put a little drop right on the part, and you come over here and you solder the other lead that's on there. The flux helps flow the solder underneath there. And when you get done, a lot of times when you're soldering this first one and you haven't used any flux, there'll be a little peak pop up on top of that. The solder gets drawn away from it, and it leaves a little hump or a peak on that. So you can come back, put a little bit of flux on it, come to the first side, and then pull your iron away from it like this. And then what you'll wind up with is a nicely soldered little part. So it's pretty easy to do. I realize that some people's vision is not as good as, I shouldn't say mine because it ain't all that great. And their hands may be shaky, so you may have to use some other means to hold everything in place. Fortunately, I can rest my hand on the board and it gives me enough steadiness that I can move the part around and get it where I want it. So, in a nutshell, that's how you solder about anything on this board, whether it's a resistor or a capacitor or anything else. I will show you how to do one of these parts. This is a fairly easy part to solder. It's called an SOIC, and the part that goes on it looks like that. And I can't remember how many pins that's got on it, about 20, I think. And so it's going to go on those pads roughly like that. This is the idea. So here's how we do it. And there's a couple of ways you can do it. One thing is make sure you put the part on in the right polarity. The people put a little mark on the board here. That indicates pin 1. You see on the chip right here, if you can see it, there's a little dimple right there. That indicates pin 1. So that's the orientation that the part goes on. It's like I've shown it right there. So you do this the same way pretty much that I just did. You put a little blob of solder with a clean tip on one of the corner pins. I'm going to pick that one. Then you take your tweezers and you try to grab between at least a couple of the pins here so that you've got some control over the part rather than just trying to grab it on one pin. And you move the thing over and you get it really close, you melt the solder and you push it into place. And you kind of be mindful of where all the rest of the pins are. Now, in this case, I've got it scooted a little bit too far that way, so I'm going to try to reposition it just a little bit here. Now, with one pin soldered in the corner here, you can still move it a little bit and make sure that you kind of got it straight on the board, which that one actually came out pretty straight. Now then, you got to solder the rest of the pins. There's two ways to do that. One way, and you got to use solder flux. Either way you go, you got to have some of this stuff. You put some flux on it. You put a little bit of solder on it, and you can actually solder the individual pins by touching it right here and then pulling the iron away from the pin like that, and that will solder the pins. And you can very carefully go down each and every one of these and do the same thing. The other way to do this, and this works fairly well on even parts like this, if you're real careful, where you've got really, really fine spaced pins, you can do this. You can come in here, you put some more flux on it. This stuff evaporates pretty quick. See if I can do this. Sometimes I can do this, sometimes I can't. Put some solder on it, and you just start going down the pins. And you will notice, you probably can't see this in the video, but the solder follows the heat of the soldering iron. And you go down there, and I've soldered every pin on that side of that chip, just like that. It's real easy. Got to practice at it a little bit, but it's easy to do. I will turn it around here. I'll see if I can do the other side. Sometimes I get lucky. Start up here at the end, put a little solder, and then just kind of start clicking down through the pins like this. At that time I got a bridge. And you can see the solder follows the heat of the iron. And when I get down to the end, that's it. So I've soldered all, however many pins there are on that side of that part. Now, what will usually happen is you will get a bridge. And I'm going to purposely bridge something here, if I can. Okay. I don't know if you can see that, but I bridged a couple of pins right here. So, again, there's a couple of ways to get rid of the bridge. One way is to use this stuff, which is solder flux, or solder wick rather. And the key to that is put a little of this solder flux or stuff on it to kind of, even though there's flux inside this braid, and then you get right up against the thing and you can put enough heat on it and it'll pull all the solder away and it clears your bridge out. That's one way, but I'll show you the way I like to do it. I'm going to bridge it again. Okay, there's a really nasty bridge. Here's the best way to get rid of them. If you don't have anything that you really worry about breaking on your board, like crystals or things like that, you kind of heat it up and then you go like that. And then you go back and you resolder it to make sure you didn't completely knock all the solder off the pins. And that's how you clear a bridge out. So that's how you can put this stuff on by hand. You do not need a soldering iron like this one. Some guy that was here, he claimed he had to have this little bitty, it used to have a point on it right here. It's been broken off. You do not need a little bitty teeny soldering iron to do this. By the same token, you don't need one of those big Weller 140 watt gun soldering irons either. I put my first Heath kit together with one of those and learned a lesson there. So guys, that's how you hand put surface mount parts on a circuit board. It's really not very hard. You got to have a decent iron. You got to be able to keep the tip clean, and you didn't see it probably, but there's a little sponge up here that has moisture on it. It's wet. It's wore out. But you got to be able to keep the tip of your soldering iron clean, and this magic elixir right here is a must-have. You have to have that stuff. Now, you noticed I put that all over this board. This is some stuff called No Clean, and you can find it, I guess, on Amazon. We used to use a brand made by Kester. I think this is something different now, probably cheaper. And it leaves a residue kind of on the board, and even though it evaporates, you can still feel it on there. It's called No Clean because you don't really need to clean it. You can put this board straight into operation. There's no residue that will affect the performance of it in a normal system. However, it's probably best to wash it with a little alcohol to get most of it off, and then use soap and water and clean it up, as long as you don't have anything on the board that the water can get into and hurt. So guys, you need solder flux, liquid solder flux. You need a good iron. A pair of tweezers doesn't hurt. These are indispensable for me. I've had these for many years. And in a nutshell, guys, that's how you put parts on a circuit board. Surface mount parts on a circuit board. Try it.
Cool. Okay, good morning, fellow club members, and it is morning. Tom and I are out here in the backyard of my house. I'm Chuck, call sign is KM5G, and we're going to talk for a few minutes this morning about Yagi antennas, and then about specifically an antenna I'm building and almost done with that I'll hopefully put up in the next couple months and use. So this particular antenna that I'm building was designed specifically for the WRTC competition. The WRTC, it stands for World Radio Sport Team Competition, and it's held every 4 years, sort of like the World Olympics. It's basically the Olympics for amateur radio contesting. I don't know, a lot of you folks may have operated during the IARU contest, which is every year. It's held the second weekend in July, and every 4 years or so, the WRTC is a part of that contest. So it's a contest within a contest. They form a committee. They have a WRTC committee which accepts bids from host countries to put on this event, because it's a mammoth undertaking in both dollars and support personnel that are needed to pull this thing off. Just think of the Olympics and what's involved with the Olympics, and that'll give you some idea for the radio contesting Olympics here. So there's roughly a 2-year competition period before the WRTC is held that will determine the competitors for the contest. So the contest, the WRTC was last held in this country in 2014 in the Boston area. And, excuse me, they selected 52 teams for the competition. So each participant that was selected then got a chance to pick a teammate. So there's 52 two-man teams for this competition, and each team has an embedded referee. So basically, the whole idea of the competition is to eliminate all the advantages in an HF contest and put everybody on an equal playing field where they can then determine who the best operators are. So to give you an example of how this works, just imagine having to put together 65 identical field day stations, and they're all identical. They start with having to find 65 different locations that are all roughly as equal as they can make them. In other words, you don't want one team up on a hill and another team in the valley. They all have to have equal topographical features. Like I said, the 2014 running of the WRTC was in the Boston area. The next running will be in 2022 in Italy. So, anybody that's interested in the WRTC, there's a great book out. It's called Contact Sport. It's available in Kindle edition as well as hard copy. It's by this operator, N3BB, who wasn't a participant in the WRTC, but he was embedded with one of the German teams and gives basically an hour-to-hour breakdown of the contest. It's a pretty fascinating read. So, this particular antenna that we're going to talk about was developed specifically for this competition in 2014. The WRTC committee put together a list of criteria for this antenna and then sent out requests for pricing to anybody that wanted to submit a design and build 65 of these antennas. So I think at this point, Tom is going to zoom in on some of the criteria for this particular antenna. And as you can see, it's pretty detailed. They wanted an antenna that was lightweight, easily assembled. Boom length couldn't extend over 18 foot. I think the weight could not exceed 35 pounds. And it had to have true monoband performance with one feed line. So our club member, K5GO, and his son, N5DX Kevin, they submitted the winning proposal. They teamed up with an engineer in New York, WU2X, Scott, and together they put this proposal together. They were awarded the bid, and they built 65 of these antennas that we'll talk about here in a few minutes. I believe that Scott, who had an engineering background, did all the electrical calculations and the electrical design. Stan and Kevin did the structural design and actually did the physical assembly of the antennas. You can go online and Google K5GO and they'll give you a whole bunch of information on this specific antenna. One thing that I found that was really fascinating was there's a picture of Kevin there between two drill presses, and I think they figured out that he had to drill over 4,500 holes for these 65 different antennas. Okay, let's stop there for a second. So here we are at this particular WRTC antenna that K5GO and N5DX built 65 of them, but we're just building one here. Believe me, one is quite a bit of work. I can't imagine 65 of them. So this is a tri-band Yagi antenna. It covers 20, 15, and 10. It's extremely broad-banded. It has great gain. And again, you can go online and look at all the specific SWR charts, gain plots, all that good time stuff if you're interested. It has 2 full-size elements on 20, 2 elements on 15, and 4 elements on 10 meters. And it's on a 15.5-foot boom. That was some of the criteria for the design and submittal for this particular project. It has one single feed line, and we'll talk about the feed line here in a little bit, but one of the criteria for the contest, the WRTC, is that it's a 2-man team. So if you have the right equipment in your station, you could have 2 different operators using this same antenna at the same time. One on 20 and one on 15, or 15 and 10. That was one of the design criteria for this antenna. Of course, here I'm a single op, so I just use one band at a time. So, let's go ahead and talk first about some of the common materials that we use for an antenna like this or any similar antenna that you guys decide to build. Okay, let's hold it there. Okay, you guys, so any Yagi antenna similar to this or any commercial antenna that you buy, there's a couple key components that every antenna uses. One is aluminum tubing. So all of this, the tubing for this particular antenna is what they call 6063 aluminum tubing alloy. And here I've got a sample of a 3/4 inch piece of aluminum tubing. The wall thickness is very important. It's 0.058 of an inch. Can you get a close-up of that, Tom? So remember, this antenna had to withstand 80-mile-an-hour winds. So this stuff is readily available. It's not cheap. This is the most expensive component of any antenna, is the tubing. But you can get this tubing from DX Engineering or Texas Towers. It comes in 1/8 inch increments where the sections will slide together and nest inside of each other. So we'll talk about that in a little bit. It's available in either 6-foot or 3-foot lengths. And it's pretty handy stuff. But again, not cheap. All the hardware for this antenna, without exception, well, there's one exception, it's all stainless steel. So all the boom components, the hardware for the boom components are 1/4-20 size. So what is 1/4-20? 1/4-20 simply refers to a 1/4 inch diameter bolt, 20 threads per inch. That's all it means. So for the boom, we have two different types. We have a button head and a flathead screw, all stainless steel. That's what the boom is composed of. The elements are composed of number 8 by 32 and number 6 by 32 socket head screws with nylon lock nuts. These are great. They have a nylon insert in them, or what they call a kept nut, which has a built-in star washer on the hex nut. Again, everything is stainless. Okay. That's good on that, Tom? Back at the antenna, you can see from the design of the antenna, all the elements are insulated from the boom. And K5GO developed this clamp mechanism here. I think this is all fiberglass. It's made for the oil industry, but he found these online, and then he had these metal plates. I'm sure he had these made at a machine shop because he had to do so many of them. It's just 3/16 inch aluminum plate, and again, all 1/4-20 stainless steel hardware. So if you can see, if Tom will give you a close-up of one of those clamps, the clamps go around the boom, and then the elements mount underneath the boom there. And it's specific for each size. Okay, let's hold it there. Okay, so I'm at the end of the antenna, the director side of the antenna. This is the number 2 director for the 10-meter array. As you can see, these clamps just slide up on the boom. Now, obviously, if you buy a commercial antenna or take an antenna down from somebody, all the critical holes are already drilled. And you don't pretty much have to deal with some of this stuff. When Stan and Kevin built the 65 antennas, they shipped them with this component already in place so that the assembly team could just slide in the pieces of the elements. So this is a typical element. This is the 10-meter second director. It's composed of a 6-foot piece of 1/2-inch OD aluminum tubing, and then you can see it's telescoped in with a piece of 3/8 inch tubing to complete the required length. So what I'm going to do here is take this piece of 3/8 tubing. Now, one of the key things about antenna constructions is to use this anti-oxidation compound that I'm going to apply here on this section. And we don't want to lick the spoon. That stuff is nasty. And it slides in the 1/2-inch tubing. You have to have a drill press to drill all these holes. That's the one thing I had to get. And then a 632 by 1-inch socket head screw that goes through, and you can see that the hole on this 1/2-inch tubing is a little bit bigger, and if you get the holes to line up just right, the socket head of the bolt will nestle down in the 1/2-inch size tubing. And then your nylon nut goes right up there. You tighten it down, but before you tighten it down, another thing here, important to remember, the only drawback to stainless steel hardware is it has a tendency to seize or lock up. And if you've ever been on top of a tower and you've had a piece of hardware that stainless steel seized, you cannot get it loose. It's a real bummer. So with this little compound, it's anti-seizing compound, you just put a little dab on the threads before you tighten it up, and that will hopefully clear that issue up. And at that point, I think we can pause. Okay, now here's a little close-up of the 15-meter driven element. As you can see, it's got a short piece of fiberglass solid rod that splits the element in two. I've drilled some 832 bolts through here, through the solid fiberglass rod, and this will give us an attachment point for the feed line assembly. Now, this is very similar to building a half-wave dipole. It's your frequency divides into 468, which gives you this length. You split it in half, just like if you were building a dipole, with the center insulator, and the coax goes on both sides of the insulator. And then this thing will mount under this plate, and it'll get a feed line point attachment at that point. So, let's pause there. And then finally, this is where your feed line attaches to the antenna. This is a standard 1-to-1 choke ballon that's readily available from a number of suppliers. It has the coax at this end is split, and it's a eye-type fitting that's crimped on the end of the coax. It bolts onto your 832 studs that go through the fiberglass insulator to the antenna. Now, I haven't completed the phasing lines, but you can see this is just a pair of number 14 wires that have a crimp-on eye. This is the 10-meter driven element. The phasing lines attach here, and then they extend over. You can see I made this one about 1/4 inch too short, but again, these are just temporary to give you an idea. These will bolt onto the stud, and then you'll have the same pair of phasing lines that go from here, the 20-meter driven element, over to the 15. And that pretty much takes care of your feed line. And I think we can pause there. In conclusion, this is the antenna. I'll hopefully have it completed in another week or so. I need to get it up on the roof of my house so I can cut the grass. And then I'm eventually going to put it 25 foot below the existing antenna on top of that 70-foot tower and drive them in phase. This second antenna at a lower height will increase the performance of the top antenna and more importantly for me, let my signal be split in two different directions, just at the flip of a switch. So that's the ultimate goal. And then just to give you an idea of the size of this thing, and like I said, this is considered in HF a pretty small antenna. But as you can see, with full-size elements, it fills up my backyard pretty good. I can pretty well manage this thing. It weighs roughly 30 some odd pounds, but it easily, I think, will outperform an old style trap type antenna that I've used for years. And I think the big reason for that is the full-size elements and the electrical design that Stan, Kevin, and Scott, W2X, came up with. And I think that'll complete our program for this morning. Thank you all.
Well, it looks like we're back, and I hope you found these presentations enjoyable and informative. And I want to thank you for being a participant. I invite you to stick around after the meeting and join us for a Q&A net about tonight's presentations. You do not need to be a member of BVRC to participate, but you must be a licensed amateur radio operator. We will be on the air using the NWA linked repeater system beginning at 8:30 p.m. local time. For more information on the link system, go to NWALINKSYS.org. Your comments, questions, and suggestions are welcome and encouraged. Please address these to info@bellavista.radioclub.org. Also, for more information on the Bella Vista Radio Club, visit our website at bellavista.radioclub.org. We invite you to be a member of the largest amateur radio club in the Northwest Arkansas region. We exist to serve the amateur radio community. 73, stay safe, healthy, and on the air. Good evening from W5XNA.